Today we are going to deal with something known as imaginary numbers. Imaginary numbers occur when you get a negative number under the radical. So if you look, your first blank I filled it in already for you, but please fill it in. A number in the form a radical negative 1 equals ai. I is known as the imaginary piece of the number. A is any number. I is imaginary. And the reason is because I, for our imaginary number, is represented by radical negative 1. And what we're going to do is going to do some of these problems. I'm going to skip some, and the ones I skip I'm going to ask you to do on your own before class tomorrow. So we have the square root of negative 7. The first thing you're going to do whenever you see a negative under the radical is to take the negative out. And by taking the negative out, it becomes just an I for imaginary, radical 7. From there, you look to see if you can reduce radical 7 any further. You cannot. So it's just I radical 7 as the final answer there. For the next piece, I radical 12, same idea. Sorry, radical negative 12. Take an I out and be left with a 12 under the radical. From there we can break down 12. 12 breaks down to 4 and 3. 4 breaks down to 2 and 2. Circle pairs. Pairs go on the outside, so it's going to be 2 I radical, and you write what's left, 3. Radical negative 25. I hope you can see right now that negative is going to be an I. And then radical 25. The square root of 25 is 5I. Now if you can go from just looking at the problem to the final, that is okay with me. I do not need to see that middle step if you can see how to get from the first to the third. These next two I'm actually going to skip only because they are pretty squished right there. You can try them on your own. Your paper should look a little bit better than mine does right now. For this one though, negative 5 plus 6 radical negative 150. The first thing I'm going to do is I'm going to take the negative out of the radical. So it'll become negative 5 plus 6I radical 150. And I try to break 150 down, and it does. Let's see, 15 and 10. 5 and 2. And we have 3 and 5. Pair of 5s circle. Those pair of 5s are going to multiply with the 6 on the outside. So it's going to be negative 5 plus 30I radical. And you have a 3 and a 2 left over, which will just become a 6. And that's it right there. You cannot try to combine those in any way. A few more down here we have radical negative 25 plus radical negative 49. Well, this one should be quick. We already did radical negative 25. It's 5I. Hopefully you can see the pattern. Radical negative 49 is 7I. 5I plus 7I, you can combine it. I is just like any other variable. It becomes 12I. Next one, radical 4 is 2 plus, and let's see, radical negative 32 is going to be I radical 32 plus I radical 8. And just like when we were adding and subtracting radicals before, in order to be able to do that, you need to have the same number under the radical, and right now we don't. We have a 32 and an 8. So let's simplify those. 32 breaks down to 16 and 2. 16 is 4 and 4. 2 and 2, 2 and 2. Circle up pairs. So it's going to be 2 plus, you have a pair of 2's out there. You have 2 pairs of 2's, so it's going to be 4I radical 2. Plus, radical 8 breaks down to 4 and 2, 2 and 2. Circle up pairs. So it's going to be 2I radical 2. Now we do have like terms here. 4I plus 2I is 6I radical 2. And I'm going to leave you to try that problem as well. So right now you have three problems to try in that section. For powers of I kind of went into the space a little bit here. I, you already know, you can see on your paper better than mine, is radical negative 1. Well, I squared, that would be radical negative 1 times radical negative 1. And we learned that a radical times itself just gives you the piece under the radical, so a negative 1. I cubed, it makes sense that it's I squared times negative radical 1. Well, I squared you know is negative 1. Radical negative 1 you know it's an I. So it's just going to be negative I. And then I to the fourth is the same as I cubed times negative radical negative 1. So that's going to end up being just a positive 1. And that pattern is going to repeat. It's going to be I, negative 1, negative I, 1. I, negative 1, negative I, 1. When you do these types of problems below. So I to the fifth goes back is the same as I. I to the sixth is the same as I squared. I to the seventh is the same as I cubed. I to the eighth is the same as I to the fourth. I to the ninth is the same as I. And it just keeps following that process. Now, this next part tends to be difficult for some students. So I'm going to try to take it a little bit slow here with the time that I have left. I to the 14th. Well, we could just count by fours until we follow the pattern above until we get to the correct number. But this is the little bit easier way to do it. Or quicker, I should say. What you do is you take the power and divide by 4. Always 4. Alright, when you take 4 into 14, let me show it using long division way actually. It's probably easier for you to see. Oops. Four goes into 14 3 times. 12. Subtract it, you get a 2. You have a remainder of 2. Whatever your remainder is becomes your new power. That means I to the 14th is equal to I squared. I squared, you look at your chart above, is equal to negative 1. Let's do a few more so you can see how this works. I to the 7th. What you do is you divide 7 by 4. 4 goes into 7 once. The remainder is 3. The remainder becomes your new power. So I to the 7th is equal to I cubed. I cubed, you know, is 1. This next one, you have 3I plus 2. I cubed, you know, is 1. If you look at your chart above. So this is just 3I plus 2. You cannot combine those. I'm sorry. I said this wrong. Look at the chart above. I cubed is negative I, not negative 1. 2 times negative I is a negative 2I. 3I minus 2I is I. I is your final answer here. Alright, so sorry for that mistake. Next one, we have I is just I. I squared, look at your chart above, it's negative 1. I cubed is negative I. I to the fourth is 1. Combine like terms, 1 minus I is, or I minus I is 0. Negative 1 plus 1 is 0. I to the 3, 6, 7, 2. Okay, what we are going to do is we're going to take 4 and divide by take 3, 6, 7, 2 and divide by 4. 4 doesn't go into 3. 4 goes into 36 9 times. Bring down to 7. 4 goes into 7 once. Bring down to 2. 4 goes into 32 8 times. So, I to the 3, 6, 7, 2 is the same as I to the 0. You know this from your exponents. Anything to the 0 power equals 1. I do want you guys to try this last problem in that section. So altogether you have 4 problems to try at this point, and we'll see how you do tomorrow.